All right, this is the applications of flip-flops lab, and on page 1 it describes the RS flip-flop, which we've already covered. On page 2 it deals with a JK flip-flop. In this case, we're given a circuit and we're asked to analyze it and describe how it works. So we have a JK flip-flop, which is right here. So J and K are the inputs and the output is A and A prime. And so this one over here we call flip-flop B. So this is flip-flop A and flip-flop B based on what the output is labeled. You also see that it has some logic gates. It has 2 OR gates and 1 AND gate. And the input to the circuit is X and the output is Z. And clock is the input into the JK flip-flop, which is determining how fast it goes between each of the states that we see over here in figure 6.26. So figure 6.24 is the circuit, and then this describes how the circuit should behave over here in figure 6.26. If you scroll to the very back of the document, you'll see the pinouts for the AND gate, the 7408 and the 7432, which you can use to build that circuit, but you'll also need the data sheet for the JK flip-flop. And you can go to the shelf and find the chip, which is a 7473 chip, and the pinouts look like this. Notice that the ground is on the top this time, and 5 volts is applied here at pin 4. You can see the clock input right here. And you can see that on this particular chip it holds 2 flip-flops, so you can use this one chip for that one circuit that I showed you a moment ago. And so the inputs J1 and K1 correspond to this flip-flop. Now we can call this flip-flop A and flip-flop B, even though on this data sheet they call it flip-flop 1 and flip-flop 2. Another thing I wanted to point out here is that each one of these flip-flops has a clear, so you can force their outputs to be 0. If you let this clear input right there, clear 1 and clear 2, if you let those go to 0, it will actually just make the output A and B, in our case, be equal to 0. And it doesn't matter what the inputs are, it just basically makes it numb. It clears out all the memory of what has happened before, and it just says make the output of both of these flip-flops 0. So when you want this flip-flop to function, you're going to have to take the clear inputs and tie them high so that it will behave as we would want here, so that it has this kind of behavior there. All right, so if we go back and analyze the circuit just briefly, we see that one of the things it asks us to do is figure out what happens after a few seconds of running. Remember that these two are A and B, this is Z, and that's X right here. So if we wait a long time and let X be held high for a long period of time, you'll notice that if you start in state 0, which you could do by making the clear go low, you can force it into that 0 state. If you waited a few clock cycles, you'd see that what would happen over time is that after every click of the clock, you would see that it would oscillate back and forth between these two states. You could call this state 1, I guess state 0 really, right? State 0, state 1, and I guess this would be state 2 and state 3, represented by these binary numbers that are here. But you could also indicate the state by the value of A and B next to each other. So you can see that after a few clock cycles, it goes around and it oscillates between those at whatever clock rate you have set, which we recommend a 1 Hertz clock being fed into the circuit at that location here. The next question says, with X being set low, your network should get stuck in the circuit. Well, let's see what would happen. If you held it low, it would go back and forth between these two states, or it could get stuck over here. Kind of depends. So basically, you can see that there's 2 possible outcomes for X being equal to 0. Either it can get stuck here, depending on what the previous states were, or it can toggle back and forth between those 2. And down on this 5th one, you're asked to show your instructor how you can guide the circuit through these states from the state where they're all equal to 0. So beginning with that state, show how your circuit follows the steps 3 and 4 above. So you're going to demonstrate these 2 things after you clear it and have it start right there. You're going to have it get stuck in this cycle and also in that cycle over there, and get your instructor's approval for that. All right, hope that instruction or that description helps in getting you started with this page 2 of the Flip-Flop Lab.